this video where we're going to look at experiments and observational studies. If you could take a few minutes to stop and pause the video and read the introduction problem and answer the question. The research that you just read about tried to show an association, which we also know is a relationship, between music education and grades. It wasn't a survey and it didn't assign students to get music education. It simply observed students. We call these studies observational studies. In observational studies, researchers don't assign choices. They simply observe them. In addition, we have what's called a retrospective study. So essentially what happens in a retrospective study, researchers identify subjects, like in this case, who studied music and then collected the data on their past grades. Observational studies are widely used in public health and in marketing, and those that study rare outcomes, such as specific diseases, are often retrospective. So they pull data of patients and they study that data. Retrospective studies can be unreliable though, because they're usually limited to a small part of the entire population, and they're also based on historical data and memories, which could also come with error. If we study subjects, also known as participants, in advance and collect data as events unfold, we have what's called a prospective study. So that's basically when you follow people over time. This is a more reliable approach because we can track the events in real time. Remember, it's not possible for observational studies, whether it's retrospective or prospective, to demonstrate a causal relationship. Let's look at an example. In early 2007, a larger than usual number of cats and dogs developed kidney failure. Many unfortunately died. Initially, researchers didn't know why, so they used an observational study to investigate. Suppose you were called on to plan a study seeking the cause of the problem. Would your design be retrospective or prospective? And explain why. And feel free to pause the video and answer the question. This would have to be a retrospective study. And the reason it's retrospective is because you would have to survey all the pet owners that had sick or dying pets. Surveying all the pets would have been impractical, right? It's not possible to do that. So you would locate some of the owners that had sick pets and ask them about their diets or exposure to toxins, etc. Is it ever possible to get convincing evidence of a cause and effect relationship? Yes, it is, if we use a study design called an experiment. So in an experiment, you're required a random assignment of subjects to treatments. Only then can we say things like music lessons cause higher grades, or we can answer questions like, does taking vitamin C reduce the chance of getting a cold? Does working with computers improve performance in statistics class? Is this drug a safe and effective treatment for that disease? Experiments study the relationship between two or more variables. An experimenter must identify at least one explanatory variable. Remember when we looked at linear regression, that is our x variable. Okay, but we call that in an experiment a factor. To manipulate, and at least one response variable. Remember when we talked about regression modeling, that was y. Okay, and what we do with the response variable is we measure that somehow. What distinguishes an experiment from other types of investigation is that the experimenter actively and deliberately manipulates the factors to control the details of the possible treatments and assigns the subjects to those treatments at random. So random is key, as we looked at in chapter 11. The experimenter then observes the response variable and compares responses for different groups of subjects who have been treated differently. Humans who are experimented on are commonly called subjects. Also, they can be referred to as participants. But other individuals like plants, rats, petri dishes of bacteria, etc., they're commonly referred to by the more generic term experimental units. The specific values that the experimenter chooses for a factor are called the levels of the factor. The combination of specific treatments from all factors that an experimental unit receives is known as its treatment. So the factors and levels make up the treatments. In 2007, deaths of large numbers of pet dogs and cats ultimately traced contamination to some brands of pet food. The manufacturer now claims that the food is safe, but before it can be released, it must be tested. In an experiment to test whether the food is now safe for dogs to eat, what would be the treatments and what would be the response variable? Pause the video and try to answer that question. So in this case, the treatments would be the ordinary portion sizes of 2 dog foods. We need to be able to compare, right? So we need the new food. We'll call that our test food. And then we also need the other food, maybe the old food, right? So the one that I'm certain is safe. Or it doesn't even have to be an old food. It could just be one that you're certain is safe. And then the response, remember, is what you're actually measuring. So, one way to measure the results is probably through a veterinarian's assessment of the health of the test animals. So that's probably through blood work or something like that. You can try this next problem on your own and then answer the questions, and then we can do it together. 130 patients with eligible lacerations randomly assigned to have the wound closed either with a tissue adhesive that's essentially superglue or with traditional sutures. When evaluated at the end of the study, the 2 treatments worked equally well with regard to scarring, and the adhesive was less painful and worked faster. Physicians who evaluated the scarring did not know which treatment the patients had been given. Why would this be considered an experiment? So the mere fact that they were randomly assigned, either the superglue or the traditional sutures, right? Those are considered the treatments. So since they were randomly assigned treatments, or the subjects were randomly assigned to treatments, that is what makes it an experiment. So we're going to put here, treatments were randomly imposed or assigned actually, let's say treatments were assigned to randomly assigned groups. We can even say, instead of saying assigned here twice, let's just say imposed. Okay, because they're assigning the the subjects are being randomly assigned to the treatments, not the other way around. The next thing we need to do is identify, if possible, the following. So the subject studied, okay, that would be in the problem. It tells us 130 patients were assigned to those two treatments. Next, I need to look at the factors, right? So, that's also known as your explanatory variable. And the factors here would be the types of treatment. There's actually two levels, though. So the levels would be either the superglue or the traditional sutures. So when we talk about treatments then, treatments is just factors times levels, right? So here we've got 2 because we have one factor and 2 levels. Okay, the factor is just the type of treatment, and the levels are either they're getting the superglue or the traditional sutures. And then the response variable, what are we measuring here? So the 2 treatments, as we go back and look, it says that when evaluated at the end of the study, the 2 treatments worked equally well with regard to scarring. The adhesive was less painful and worked faster. So that is our response variable. That is how we measured it. So they worked equally well regarding scarring, and adhesive was less painful. Okay, we'll stop there for this video. Please, make sure you watch the next video where we're going to talk about the 4 principles of experimental design. Have a great day, everyone.